Okay, continuing with Descartes' rules. I'm going to just do a couple more and hopefully this will help out a little bit. For example, if I have 5x cubed minus 6x minus 4 is equal to 0. Or using Descartes, what will that look like? So let's draw our plus, minus, I. And we know it should equal 3 because our highest degree is 3. So if we plug in, I think I used red for positive, we plug in f of x, so we have 5x cubed minus 6x minus 4 plus minus minus, so I have 1 sign change, so 1 positive. If we plug in negative x, we have negative 5x cubed plus 6x minus 4. Negative, positive, negative. I have 1 sign change, 2 sign change. That makes sense. Now we know that we can do imaginaries in doubles. So if I have 2 here, clearly can't borrow 2 from the positive, so it must be here. And that still equals 3. And I'm all done. Let's go to a more advanced part. If we had 2x to the 4th minus x cubed plus x squared minus 3x plus 4 is equal to 0. And we kept it as a positive, and we plugged in x. We have plus, minus, plus, minus, plus. So I have 1, 2, 3, 4. So again, if we put it back into this drawing, so 4 positive, so that would mean 0, 0, and 4. But let's put in a negative to begin with to see if that would hold true. So if we put in negative x, we get 2x to the 4th plus x cubed plus x squared plus 3x plus 4. So plus, 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 plus. So no sign changes. Well, here's where it gets interesting. We know that we could borrow in 2. So we could have 2, 2, 0, 2, or 0, 0, 4 as a possibility. How about one more? What about, let's do 3x to the 4th plus 2x cubed minus 4x plus 2. We put in a positive. We have 3x to the 4th plus 2x cubed minus 4x plus 2 plus, plus, minus, plus. So we're looking at 1 sign change. If we plugged in a negative, we have 3x to the 4th minus 2x cubed plus 4x plus 2. So plus, minus, plus, plus. Make sure I did my math right. Yep. So we have 1 sign change, 2 sign change. Oh, it'd help if I actually counted correctly. 2. And then we have 2 sign change for negative. So therefore 0. And that's 4. So if we borrowed 2, we could borrow 2 from the negative. Or we could borrow 2 from the positive. Or we could borrow from both of them and have 4. We'll talk more about this, but I want to go over all the options. How about if I just do a random? We don't know what it looks like, but I do know the chart looks like this. Say I have 4 and 3. So I have a 7-degree function. I could borrow 2 from the negative I could borrow 2 from the positive. I could borrow 4 and 2 from the negative and 2 from the positive. I could borrow 4 all from the positive. I could borrow 6 and have it all from the positive and 1 from the negative. I think that's all I could borrow. So it's all about where you could borrow from and making all the options equal to 7.